When solving right triangles using the sine, cosine, and tangent ratios, and including the Pythagorean theorem, one of the first things you want to start with is making sure that you label your triangle correctly. So the right triangles will always have a right angle. You'll see that in the corner, which means that we have two sides coming off of that right angle, which are the shorter sides, okay? Shorter sides, and a shorter side over here. And then we have a side that is opposite the right angle, which is the hypotenuse. It will be the longest, and the other two sides are always shorter than the hypotenuse. So that's something to keep in mind, okay? So labeling the right triangle is important. So let's label this right triangle in a way that will be consistent with what you'll see in the textbook and probably other areas as well. It's quite common in a right triangle to call the right angle a capital letter C, okay, capital C. And opposite the C, or the angle C, then is side C in the lowercase, okay? So sides are going to be lowercase, angles uppercase. And now, the shorter sides are going to be A and B. Now that's interchangeable. It really doesn't matter which one is A or B. My triangle looks to have this lower side a little bit longer, so they're not equal, but it really doesn't matter which one I call A or B. It's just a diagram. So let's call this A up here. If that's angle A, then the side opposite angle A over here is side A, okay, lowercase. And therefore, the leftover one is B, and the side opposite B will be lowercase b. Now this is crucial, okay? We really need to be naming this way. We will also do the sine law and the cosine law, and this will be remaining constant as well. Now, over here where we see that sine theta is equal to opposite over hypotenuse. All right, so hypotenuse is always opposite the 90. But opposite and adjacent can vary. It all depends on whether the theta that you are referring to is A or B, and it will always be A or B, not C. So if the theta that I'm referring to is A, then the side opposite A is A and hypotenuse, okay, which is C. But if the theta that I am referring to is B, then the side opposite B is little b, and the hypotenuse still remains as C, okay? So opposite and adjacent flip when we are referring to either A or B. It didn't change in this notation of sine theta equals y over r and cos theta equals x over r, because x was always the horizontal, y was always the vertical, and theta was always the standard position angle with the counterclockwise rotation from the positive x-axis. So that's why that remains constant. All right. So let's do an example. We are going to solve a right triangle given that side A is 932 centimeters and side C is 1240 centimeters. So let's give ourselves a quick little diagram. It doesn't have to be perfect or to scale. All right, so C is the hypotenuse always, so that's 1240 centimeters. Oh, fix that. 1240 centimeters. There's my right angle. And so that's C. That makes this angle C. And I'm going to say that A is 932 centimeters, which means this is angle A. Therefore, the unknowns that we're looking for are B and side B and, well, angle C. It's not really an unknown. We know that it's 90. All right, so first of all, Angle C is 90 degrees. That means we're looking for B. Oh, we don't know A as well. And A. And side B. Okay. So we can't find the angles by subtraction because we only know one angle. We don't know A and B. Therefore, we need trig to find angles. So let's take a look at how to do this. I've got side A and side C. So now, with respect to angle A, what sides do I have? With respect to angle A, I have its opposite, and I have the hypotenuse, okay? So let's find angle A. We have, we know that we have the opposite and the hypotenuse. So opposite over hypotenuse is sine, right? So we can say that sine A, the sine of angle A here, is its opposite, 932, divided by the hypotenuse, 1240. Oh, all right, that's a number. Let's figure out what that number is. I will still write sine A equals, oh, what's that number? Let's get my calculator out. And it's 932 divided by 1240. Change that to a decimal. We've got 0.7516. I'm just going to write that down, 0.7516. Now, we talked about how to solve this in class. This means that if the sine of A is 0.7516, then A is the sine inverse of 0.7516. So A is equal to, let's get that calculator. I'm leaving it there. I'm not going to clear it. And I'll do second function sine and the angle. All right. Let's write it as 48.7. We'll go one decimal place on these ones, 48.7. Okay, so 48.7 degrees, right in there. Now we have two angles, 90, right, and 48.7. We know that the angle sum of a triangle, okay, the sum of A plus B plus C is 180 degrees, always. The sum of the angles in a triangle is always 180 degrees. So, to find angle B, it will be equal to 180 degrees, subtract 90, subtract 48.7. So B is equal to 180 minus 90 minus 48.7, which is 41.3. All the angles must always add up to 180 degrees. And there they do. All right, 41.3 degrees. Now, we don't know side B. So, we can use Pythagorean theorem because, let's use gray. All right, so B squared equals C squared minus A squared, or B is equal to the square root of C squared minus A squared, the square root of 1240 squared minus 932 squared. It'll be the square root. Let's get that number under the square root sign first. All right, 1240 squared minus 932 squared. 668, 976, and square root that. So square root, let's call that close enough to say 818, okay? We've got 817.9. We'll just write 818 for our purpose here. 818 818. This is in centimeters. Okay. Alternatively, we could have found B as being, let's see, we could use a sine function. The opposite of B is the unknown, so B over the hypotenuse, 1240, and this is the sine of B, which is 41.3. Okay, so you can solve this also. Solving for B is equal to 1240 times the sine of 41.3 degrees. Let's try that and see how close we get to this number. 1240 sine 41.3. 818.4. Okay, so still 818. One was just under and one's a little over. And the reason for that is we rounded with the B angle, right? So this one was using the original values. The other one was using the calculated values that we rounded, so slightly off. But as long as you keep a few decimal places, if I had kept more here, probably would have been a little bit better. But so that's solved. Solve means find all unknown values. So in the end, we want to have all three angles and all three sides. So that's solved. Okay, so here's a second example. And actually, I'm going to ask you, if you can, pause the video and start to give this a try yourself. At least label the triangle and mark which values you need to find out. If you can go further than that and find some of the values, then go ahead. So pause the video now, and after you can unpause and I will be going through the solution. All right, so I'm going to call this one B. B is given at 64.3 degrees. We also know C is a 90. Side B is 0.652 meters. Side B must be opposite angle B, so B is 0.652 meters. That means that angle A is an unknown, side C is an unknown, and side A is an unknown. So we cannot use the Pythagorean theorem yet to find an unknown side because we only have one side. However, we do have two angles. We have angle B and angle C. So I can find angle A by subtraction, right? I know that the sum of the three angles is 180 degrees. So it will be A equals 180 degrees minus 90 minus 64.3. We could also, we know that A plus B must be equal to 90 since we have a 90. So we could just subtract 64.3 from 90 as well. So this becomes, let's do that one, 180 minus 90 minus 64.3 leaves us with 25.7 degrees. All right, so that's given. I mean, not given, that is determined, 25.7 degrees up there. Okay. How about we find side A, okay? We could find A or C next, it doesn't matter. We're going to be needing trig because we don't have two sides. So let's find side A next. So find side A. And let's see. Side A is opposite 25.7. It's opposite angle A. And B is adjacent to angle A, right? So opposite over adjacent is tan. So we can say that the tan of angle A, and I'll write it as a formula first. Tan of A is A over B, right? Tan of A is its opposite over the adjacent. So now we'll just put the numbers in. Tan of 25.7 equals A is unknown over 0.652. Solve for A means we just have to take this value and multiply it up here. So A is equal to 0.652 times the tan of 25.7 degrees. Type that in the calculator exactly as I wrote it, okay? 0.652, and you can press multiply, but you don't need to. Tan 25.7. 0.31, and since the digit after the 3 is a 7, I'm going to put 0.314, 0.314. It's in meters. All right. And lastly, find side C. So C is the hypotenuse. Well, C squared equals A squared plus B squared. We could use that. That means we're going to be using a calculated value that I just rounded a bit, right? We could also use our angle and the opposite side of it. So I'll show both ways, okay? So one, we're going to be using Pythagorean theorem. C squared equals 0.314 squared plus 0.652 squared. C will be the square root of whatever that sum is. So let's just go and find that. 0.314 squared plus 0.652 squared. 0.5237, and let's see what that is, a square root. 0.724 meters, and that is the longest. It's a little longer than the B, okay? So it should always be the longest, just double check that. It's longer than both of those sides. The alternative method would be to find C. C is the hypotenuse, and we've got angle B and its opposite side, opposite over hypotenuse. So 0.652 over C is a sine of 64.3, right? The sine of 64.3 is its opposite side over the hypotenuse, the opposite side over the hypotenuse. All right, solving for C. Okay, so when the unknown's in the denominator, we have to be very careful, all right? Let's think of that as over 1. Now we can use the proportion method, cross multiply and divide, right? So multiply C by sine 64.2, C sine 3 equals 1 times 0.652. All right, so I'm just multiplying those two and then those two. Set them equal. I want to solve for C. It's multiplied up here, so we must divide by that. So C is equal to 0.652 divided by sine 64.3 degrees. Let's see how that works out with the calculator. Keep it on there. 0.652 divided by sine 64.3. Okay. 0.724. Very good. 0.724 meters. Great. It works out to be very much the same, okay? So we do have options at times. Okay, so we'll pause here and let you catch up with that in case you're making some notes. Okay, so here's one more. We're given side B 2.95 meters and side C 5.08 meters. You can see that this one is the hypotenuse because it's labeled C. So this is one of the shorter sides. Let's give ourselves a little triangle. Actually, go ahead, if you want to pause the video now, go ahead and give it a try, okay? When you unpause, I'll be completing it. All right, so let's see. We've got a right-angled triangle. C is opposite the 90, so here we are with C, 5.08 meters, and B, 2.95. So I'm gonna put it here, 2.95 meters. I'm not sure if A is going to be longer or shorter than that, so it's hard to tell before we get started. But anyway, it's just a diagram. All right, so if that's side B, then angle B is up here. Oh, we'll put those in red because those are the ones we want to find out. That's angle B. This will be A, and this will be side A. So that's what we need to find out, okay? All right, so we're going to have to use trig to find these two angles. So let's see. Let's start with, let's do not sine this time. Let's find angle A, since we know it's adjacent side and the hypotenuse. What's adjacent over hypotenuse, which is this is finding A. Angle A. Adjacent A over hypotenuse is 2.95 over 5.08. Adjacent over hypotenuse is cosine, right? So this will be equal to cosine of A. All right, let's find out what that is when we divide it. 2.95 divided by 5.08. 0.581, let's say, 0.581. So cos A equals 0.581. I'm not going to use 0.581 though. I'll use what's on the calculator and we have to find A, we have to say cos inverse of 0.581. So leave it all there is best. Second function cos equals 54 point. Let's make that a 54.5. Okay. If A is 54.5, now A and B add up to 90. Since one more 90 with the right angle makes 180. So finding B, angle B, we have B is equal to 180 degrees. Oh, sorry, we were going to do it from 90, weren't we? 90 degrees minus 54.5 degrees. So B is equal to 90 minus 54.5. 35.5 degrees. All right, finding side A. Well, A is one of the shorter sides. We have the hypotenuse and the other shorter side. So we do know, we've seen the relationship that A is equal to the square root of the hypotenuse squared minus the other shorter side squared. Remember that minus has to be in there, okay? So A is equal to 5.08 squared minus 2.95 squared. Let's see what that number is under the square root sign. 5.08 squared minus 2.95 squared. 17.1039. And when we square root that, 4.14. and that was in meters. All right, and that is shorter than the hypotenuse, so that checks out. Everything is good, though. That triangle is solved. All right, thanks for watching. Bye-bye.